In this lecture, we'll be discussing another sort problem on first come, first serve scheduling. So this is the second problem that we are discussing on the FEF scheduling algorithm. Alright, so let's see what is the problem, and let's see how we can solve it. So here is a problem. The arrival times and both times of a set of 6 processes are given in the table below. So we have a table here where the arrival times and both times for a set of 6 processes are given. So the processes are denoted with process IDs P1 to P6. So here is the question. If FEF scheduling algorithm is followed and there is 1 unit of overhead in scheduling the processes, find the efficiency of the algorithm. So it says here that for the set of 6 processes, when they arrive at this times, and when they have this unit of both times, and if they are following a first come, first serve scheduling algorithm, and there is 1 unit of overhead in scheduling the processes, we have to find the efficiency of this algorithm. Alright, so before we go into that, let us try to understand what does this term mean. There is 1 unit of overhead in scheduling the processes. So we already know how FEF scheduling algorithm works. The process that comes first will be served first, or given the CPU first. It's what we mean. Now by this 1 unit of overheading scheduling processes, what we mean is that when a process arrives in the RDD and is to be given the CPU cannot be given just at that particular instant. That means exactly at that time. The CPU cannot be given to the process. The system has a delay, a slight delay of 1 unit, before it assigns the CPU to each processes. So whenever a process arrives, the system will have 1 unit delay in assigning the CPU to the process. And even when the CPU is switched between processes, there will be 1 unit of time delay in switching the CPU between the 2 processes. So 1 unit of time delay will be there. So that is what we mean by 1 unit of overhead in scheduling the processes. So if it is like this, then what will be the efficiency of this particular algorithm for this particular set of processes? If they arrive at this particular set of times, and if they have this particular set of birth names, let us try to find it out. So first of all, what we are going to do is we have to draw the gunshot for this. So let us see how we can form the gunshot for this set of processes following this method. So coming to the solution, we are going to form the gunshot, and this is how the gunshot for this set of processes will look like. So let me explain this gunshot to you. It looks a bit different from the previous gunshot that we have formed in the previous example that we discussed in the previous lecture. And why is that? That is because we are having this del in this gunshot. And what is this del? This del denotes the unit overhead in scheduling the processes. Because integration, we said that there is 1 unit of overhead and scheduling the process, so that 1 unit of delay is denoted by this del over here in this gun chart. Alright, so let's see how we have formed this gun chart over here. So we see the processes P1 to P6. They arrived at this units of time. So P1 arrived at 0 unit of time, P2 at 1, P3 at 2, P4 at 3, P5 at 4, and P6 at 5. So the arrival times are 0, 1, 2, 3, 4, 5, and these are the bus times. So which is the first process that arrived? It is P1. It arrived under 0 worth unit of time. So here we are following FEF scheduling algorithm, which is first come, first served. So B1 should be the one that should be served first, or given the CPU first. So here at a 0, 8 unit of time P1 arrives, but as we know that there is 1 unit of overheading scheduling, as I told you, the CPU cannot be assigned directly at that time itself, but there will be a slight delay of 1 unit of time. So even though P1 arrived at 0 unit of time, there is a delay of 1 unit of time. So that is why we have strong this del over here. So from 0 to 1, that means for 1 unit of time, this del is shown, and exactly at time 1, P1 will get the CPU for its execution. So after this delay of 1 unit, P1 gets the CPU for its execution. Now how long will P1 use the CPU? The bus time. We have to check the bus time. For P1, what is it? It is 3 units of time. So P1 will use the CPU for 3 units of time. So 1 plus 3 gives us 4. So the completion time of P1 is 4 units of time. Now again, if we look at the table here, we see that P2 arrives at 1. The time 1, so P2 should be the next one. So if you observe this table, It is 0, 1, 2, 3, 4, 5, so obviously the order of arrival is P1, P2, P3, P4, P5, P6, so it is easy to remember for this example. So P2 is the next one that should get the CPU. But as we know that there is 1 unit of overhead in scheduling, the processes, again after P1, releases a CPU before P2 gets the CPU. There will be 1 unit delay, so 4 to 5 there is less delay over here. Now at the 5th unit of time, P2 will get the CPU. And how long will be to execute? It will execute for 2 units of time, so from 5 to 7. 5 plus 2 is 7, P2 so executes for 2 units of time, and the compilation time is 7. Now again, the next process is P3. But P3 will have to wait for 1 unit of time, so again 7 to 8 is the delay. And then, at the 8th unit of time, P3 gets the CPU and executes for 1 unit of time. So 8 plus 1 is 9. So BK executes for 1 unit of time. And again, before P4 gets the CPU, there is a delay of 1 unit of time. So 9 plus 1 is 10. So there is this delay here. And when P4 gets a CPU, it has to execute for 4 units of time. So 10 plus 4 is 14. So P4 executes 4 units of time. And the completion time 14. Then again, before P5 gets the CPU, we have to wait for 1 unit of time. So it comes from 14 to 15. And P5 executes for 5 units of time. So from 15 to 2015 plus 5 is 20. So P5 uses a CPU up to the 20th time. And then again, there is a delay of 1 unit of time. So 20 plus 1, 21. And then lastly, P6 gets a CPU. And it has to use a CPU for 2 units of time. So at the 21 unit of time, B6 got the CPU and it executes for 2 units of time. So 21 plus 2 is 23. So this is how we form the Gantt chart for this set of 6 processes. When there is a unit overhead in scheduling the processes, and when they arrive at this particular time with this particular bus times, if we see the entire time it took for these 6 processes to complete execution was 23 units of time. All right. So we have this information with us, and with this, let us try to calculate the efficiency of this algorithm, and let's see how we can do that. So to find the efficiency of this algorithm, there are certain values that we need to first calculate, and let's see what they are. So the first one is the useless time, or the wasted time. So we see that this del, which was the overhead in scheduling the process, is the time that is wasted. That time was not being utilized by any processes, and it is the useless time, or the wasted time. So how much time did we waste? We have 1, 2, 3, 4, 5, 6, so we have 6 units of del over here, and we already said that the overhead is for 1 unit of time. So all this del represents 1 unit of time. So 6 dels into 1 unit of time. Hence we have 6 units of time that is wasted, or which was useless. And then next we have the total time. The total time that was taken for this entire processes to complete their execution. So if you look at contracted is 23. The last process, P6, completed its execution at the 23rd unit of time. So the total time is 23 units. And then we have the useful time. So from these 2 values we can calculate the useful time. So what is a useful time? The useful time will be the total time minus the useless, or the wasted time. So the useful time will be 23 units, which is a total time taken by this processes to complete their executions, minus the useless time, or the wasted time, which is 6 units of time. So that gives us 17 units. So the useful time is 17 units. All right. So from this, now let us calculate the efficiency. So the efficiency will be calculated like this: useful time divided by the total time. The useful time that was spent divided by the total time that was taken. So what is a useful time? It is 17 units. And what is a total time that was taken? It is 23 units. So if we divide 17 by 23, we get 0.7391. And if we convert it to percentage, it is 73.91%. So this is the efficiency of this algorithm for this particular set of processes when they arrived at the particular given arrival times with the given birth times, and when there is a overhead of 1 unit of time in scheduling the processes, and when they follow the first come, first serve scheduling algorithm. So that is how you calculate the efficiency of a particular algorithm, depending upon the type of processes and depending upon the delays that is given. So I hope this was clear to you. Thank you for watching, and see you in the next one.